Okay, so here's our problem, practice problem 5 on page 476. This is a modified example problem. So you get most of what's given by reading the example. You have these two charges, a 6 microcoulomb charge here, a 1.5 microcoulomb charge here. They're 3 centimeters apart. And then this is what they changed from the example problem. This is now positive 3 microcoulombs. And we want to know what is the applied force. So we're going to use Coulomb's law to do that. So let's do, so what's the force on A? Well, let's figure out what force B is applying to A. So this is what I do. The force of B on A, okay, we're going to use Coulomb's law to do that. So this is K, QA, QB over R from A to B squared. That's Coulomb's law in the r hat direction. And then we plug in our values. So this is 8.99 times 10 to the 9 Newton meter squared per coulomb squared times the charge on A, which is 6 microcoulombs. And remember to type in times 10 to the negative 6 whenever you see that micro. This is going to be 3 microcoulombs over r squared, which is 0.04 meters squared. So the square meters cancels the square meters there. The coulomb squared cancels the coulomb squared there. You have newtons, which is what I want my force to be. So the force of B on A is equal to, well, now they did all the arithmetic. Oh, and now we have to worry about the r hat direction. This is r hat direction. We'll worry about that direction here in a second. Now this isn't any different. This is just like what they did in the example problem. So I'm just going to look at the example problem. A and B, you type in all those values and you get 100 newtons. Is that right? You get 100 newtons? We only have 6 minutes left, so I don't want to take the time to multiply it, but well, so it's 18 divided by 4 times, well, maybe, you know what? Let me make sure. So we'll take the time to do it. So we have 8.99 times 10 to the 9 times 6 times 10 to the negative 6 times 3 times 10 to the negative 6, right? Negative 6, that's what the micro means. And I got to divide all that by 0.04 squared, and I get 101. Okay, it wasn't quite 100. Rather than round it off that much, I'll just say 101 newtons. Okay, I think they're rounding it off to 2 significant figures, but I'll keep 3. Now, what does this r hat direction mean? It means, since these are 2 positive charges, r hat means away from. So what direction is away from QB? These things are pushing each other apart, aren't they, with 101 newtons of force. But if I'm looking at QA, this is 100 newtons. It's pushing it to the left. Okay, now let's look at the force that QC applies to QA. So this is the force of C on A. And so you go through the same equation, KQA QC over the distance from A to C squared in the r hat direction. Now you plug in all those values, 8.99 times 10 to the 9 Newton meter squared per coulomb squared. Sorry for all this. And then this is going to be, A is 6 microcoulombs. But now C is only 1.5 microcoulombs. They're both positive charges. So this is all going to be, and this is 0.03 meters squared. And when you do, and this is the r hat direction, when you do the arithmetic, I'm just going to use the book's value, is 9.0 or 90 newtons. Okay? So yeah, this charge is less, but this distance is less. So it's almost the same. Now, but what direction is the r hat direction? This is the trick. What direction is the r hat direction? Well, these are repelling each other, so they're pushing each other apart, right? The positive r hat means they push each other away. Well, that means that the force on A is up. So now what we can do is use those graphical methods. I've got two forces acting on this charge. I've got a 90 Newton force pushing up, and I've got a roughly 100. We'll just stick with what the book did. They rounded it off to 100 newtons to the left. Now I'm going to add these together. Okay, because I have to add these. So I'm going to call this negative 100. Why? Because it's in the negative x direction. And so now I can say, well, what's the overall force on A? Well, these are perpendicular to each other, so I can add them together, pick this up. So remember, vectors are hooked up head to tail, so this is going to be 100 like this and 90 like this. And so you use the Pythagorean theorem. You got the x squared plus the y squared. And when you do that, you get 130 newtons. So that's how strong the force is. But what's the angle? Well, you take the inverse tangent of the y value over the x value. What is x? To the left, to the left. So that's negative. What do you do? What do you do when you use inverse tangent and your x component is to the left? You add 180 degrees to your answer, because this is going to give you a negative angle. So you do the inverse tangent on this, you get a negative angle, you add 180 degrees to it, and what you get is, let me find it. I think you, $138 degrees, I believe. Well, let's just do it. I got 1 minute left. I'm going to use it. So we've got the inverse tangent of 90 divided by negative 100. Enter. You get negative 41, so I'm going to add 180 to that, and you get 138, just like the book said. Okay? So that is how you figure out the force on one charged particle from the charges on the other charged particle. Any questions on number 5? Doesn't it all make sense now? Yay, okay. Yep. A lot of Christian's head is exploding, but okay.